Alright, welcome to Unit 3, Lesson 2 video regarding the area of regular polygons. As a refresher, a regular polygon is a polygon where all the sides and all the angles are the same measure. So that being said, we know that the distance from the center to each vertex must be the same length. That's because it's a regular polygon. Now this is a new word for you. This is the word apothem. Okay, the apothem is this red dashed line here, and it's from the center, a perpendicular line to the side. Okay, so this is a pentagon, a five-sided figure. It will have 5 different apothems. Okay, just like it has 5 different lines from the center to each vertex. Now, there is a way to find the central angle. Okay, so this right here is a central angle. In fact, each one of these corners, these angles, are called central angles. And the way we find the measurement of this angle is that we do 360 divided by n. The reason for this is if I were to draw all the way around, this makes a circle. And a circle we know is 360 degrees. It is also divided in this case into 5 equal corners because it's a pentagon and it has 5 central angles. So in order to find this angle, I would do 360 divided by 5. And when you type that into your calculator, you get 72 degrees. Okay? That is very, very, very important. Alright, so before we get too far forward, what I'd like to do is throw in a little secret surprise. Remember that I always do this, okay? These are Sour Patch Kids, one of my favorite candies. And you know how they've introduced the new blue raspberry guy? I will tell you this though. My absolute favorite though is the green one. Okay? So I may ask you what my favorite Sour Patch Kid is. Be prepared to tell me the green one. Okay? Alright, so how are we going to use this information to find the area of this regular polygon? Okay? First thing you need to notice is that each one of these side lengths right here, we use the letter S to denote side. And this dashed line here that we called the apothem is used little a for apothem. Now the area of each triangle is actually going to be 1/2 times the apothem times the side, because the area of a triangle is 1/2 base times height. This is the base of triangle FCE, and this is the height of triangle FCE. So it is our job to find the area of the triangle. Now, the total area of the polygon is the area of this triangle times however many sides, because that's the same number. So I have the area of the polygon is the number of sides times the area of each triangle. In this case, I have 5 triangles, so once I find the area of the triangle, I multiply it by 5. Okay? Another way to think about this is actually 1/2 the apothem times the perimeter. Okay? Because if I have 5 sides, then it's 5 times the side length. Okay? So all I did here was multiply n times s, and that gave us the perimeter. Okay? So the perimeter is the area of the polygon is 1/2 the apothem times the perimeter. Alright, so if we take a look down here, this is the formula again for a regular polygon. It's not on your formula sheet, so you actually do need to memorize this or remember how we came up with this formula. So let's go ahead and do an example real quick. This is find the area of the regular heptagon with the side length of 2 and round your answer to the nearest tenth. So this is the side length of 2, okay, and we need to find the apothem. We actually can find the apothem using our right triangle trigonometry. Now the first thing we need to do is go back to this formula here where we said 360 divided by n will get me the central angle. So 360 divided by 7 will give me this angle I just marked in here, 51.4 degrees. Now what I want to do is I would just want to look at this triangle right here. So let me get a different color. There we go. This little triangle right here. I know this whole angle right here is 51.4 degrees. Because this is a regular polygon, excuse me, it's actually, this little triangle is going to be half. So what we have here is a triangle that looks like this. Here's the right angle of the apothem. Here's our apothem that we don't know the length of. And this angle is going to be half of 51.4 degrees, so 25.7 degrees. We also know that this side length here is 2. If we cut it in half, this is a 1. Okay? All we have to do now is use trig to find the length of A. So this side, 1, is opposite of 25.7 degrees, and this is my adjacent side. So I will be using tangent. Tangent of 25.7 degrees equals opposite over adjacent. So A equals 1 over the tangent of 25.7. So let's type it in our calculator. Now I know that the problem says round to the nearest tenth. Let's go ahead and round to the hundredth, because in the end, if we round too soon, it may change our answer. So the apothem is 2.08. Now we also know that each side of this heptagon is 2. And the perimeter is just 2 times the number of sides, so that should be 14 feet. Now we know the formula of the area of a polygon is area equals 1/2 the apothem times the perimeter. So this is 1/2 times our apothem of 2.08 feet times the perimeter of 14 feet, and that will give us 14.6 feet squared. And that is the area of a regular heptagon with a side length of 2 feet. Alright, let's do another example. Here we have a dodecagon. Remember that a dodeca means a 12-sided figure. And this time it has a side length of 5. Okay, first things first, I'm going to draw my triangle. Whoops, it's supposed to go into the center. Okay, there we go. Close enough. And this right here would be our apothem, A. We know that this side length is 5 centimeters. So if I pull out this little triangle right here, I have 2.5 for this side length, a right angle, and my apothem. Now to find the interior angle, I would do 360 divided by 12. Let's see, put that into my calculator, 30 degrees. Now the whole angle of the blue triangle is 30, but I only want half of it, the green triangle, so that's 15 degrees. So what I need to do is I need to use tangent to find the apothem. 2.5 is opposite of 15 degrees, and the apothem is adjacent. So tangent of 15 equals 2.5 over the apothem. So the variables down low, you would divide them. So 2.5 over the tangent of 15, and my apothem is 9.3 centimeters. Now to find the perimeter, all I do is each side length is 5, so it's 5, 5, 5, 5, all the way around. So 5 times 12 gives me 60 centimeters. So now I just take this information and plug it into the formula. Area equals 1/2 times the apothem times the perimeter. So 1/2 times 9.3 centimeters times 60 centimeters gives me, 279 centimeters squared. Alright, why don't you actually try this one? This is a regular octagon, which means 8-sided figure, with a side length of 4 centimeters. Take a minute, pause, and try this problem on your own. Okay, so hopefully you've already done this problem and you're just trying to see, hey, if you did it right. So I'm going to pull out this little small triangle inside of here. Half of 4 is 2. This is my right angle. This is my apothem. Now it's an octagon, so I would do 360 divided by 8, and that's going to be 45 degrees. However, this whole angle of the black triangle is 45, but I need to cut it in half, so the angle that we get here is 22.5 degrees. So the tangent of 22.5 equals 2 over A. My apothem is equal to 2 divided by the tangent of 22.5. So typed into my calculator, the apothem should be 4.8 centimeters. Perimeter is pretty easy. It's a side length of 4, so I just multiply it by 8 sides. 4 times 8 is 32 centimeters. And then I would plug it into the formula. Area of a polygon equals 1/2 the apothem times the perimeter. So 1/2 times 4.8 times 32 gives me 76.8 centimeters squared. Alright, so that's how you would find the area of a regular polygon. I will see you in our next video.